So there's 3D. So you're handing in today the 2D moment, and you should have done the right-hand rule method and the vectorial method for both, and you should have gotten the same answers for both. So that's the way you're checking moments. In statics, we've always been doing checks as we go along, and now that we're on the moments, with the 2D that you handed in, you were requested to calculate the moment about a point using the right-hand rule, and then calculate the moment about a point using vectors. And you should have gotten the same answers. Okay? I'll give them back to you on Tuesday because I'll grade them this weekend. So that's the same thing with the 3D. I'm going to have you do it using right-hand rule and using vectors, and it's due a week from today. So what's a week from today? I believe it's the 2nd. Correct? When we do vectors using the right-hand rule, how do we calculate our vector? So we're trying to find moments using the right-hand rule. How do we calculate the magnitude of the moment? How do we calculate the magnitude of the moment? That's positive or negative will tell us the direction, correct? I'm asking you, how do we find the magnitude first?
Force times the distance perpendicular.
We take the force and we multiply it by the perpendicular distance, and that's what gives us the magnitude of the moment. Is a moment a vector or is it a scalar? Is a moment a vector or a scalar? It's a vector. Why is it a vector? Because it has a magnitude and it has direction. So when we use the right-hand rule, we take the magnitude of the force, and magnitude of the perpendicular distance, and then how do we find our direction? Danny? Right-hand rule. So when we have it with the thumb pointing out at us, is that positive or negative? Positive. So it's when it's counterclockwise, it's positive. And how about if it's clockwise? It's negative, right? Because counterclockwise gives us a thumb going into the page. And when we're dealing with these 2D problems, what is the spin about? Which axis?
Z.
Z. So when we have a 2D problem, the moment is about the z-axis. So if we have a situation, we have a force in the x direction and the perpendicular distance is in the y, what is our moment in? Z. And when we did a 3D problem, we did moment is equal to r cross f, and we had, this is a 3D problem. If r was in the y and f was in the z, what was the moment in? The x. Okay. So what I want you to do now is one of the sheets, and I haven't taught you 3D right-hand rule yet, but we're going to do it right now. One of the sheets in the back you should have picked up for Danny when you come in. Grab one of these sheets. Let's take a look at this. And you're going to work with the person right next to you. And this is actually a workshop. So we're starting one of the workshops. And actually, I should mind that since we're starting the workshop, we put the date of that homework number 6 in here. Right? So let's put the date of when the workshops are due. So this one, number 7, is the one that we're working on now, and let's have it, I know I typically give you a week to do it, but I'm going to give you till Tuesday. just because we're gonna start working on it now, and I would be more comfortable if you're comfortable with it by Tuesday. So Tuesday, I believe, is the 28th. Correct?
Yeah.
Okay. And then I'm gonna assign the pulley workshop, but I'll assign it on Tuesday, so we'll leave that blank for now. So everybody has the dates. So what we're gonna do today is we're only gonna go down to these. In class, we're gonna do these two. But the last one I want you to do on your own to make sure that you're really clear on what's going on. Okay? Let's take a look at this. So does everybody see where the axes are? Whenever you have a 3D problem, you always look at where the axes are. Here's X, here's Y, here's Z. And the first force they want you to take a look at is the 150-pound force. We're not going to do these problems I want you to do. I'm not going to do it up here because I want you to do it together. But if we're looking at the 150-pound force, what direction is that in? It's in Z. If they want you to find the moment about X, what distance are you going to look for? Let me say it again. The force is in the Z. You're trying to find the spin, the moment about X. What's the distance going to be in? 1. Okay, how about for the 150? I have, again, we know that the force is in the Z. If I want to find the moment about the Y, what distance is the X? What distance is the X? Okay. So what I want you to do now is work with one person right next to you and do this. We're using right-hand rule, right? So right-hand rule means when I find the moment, it's the magnitude of the force times the magnitude of the perpendicular distance, and then you're going to have to use your hand in 3 dimensions. And you're really looking in 2D. So work through those right now, and then we'll go over them. So you're really learning 3D right-hand rule on your own.